Hey guys, this is Tim Shepard from the Vintage Airstream podcast. Been doing a lot of work on the trailer lately, a lot of battery and power upgrades, and of course, as you all know, I did the GoPower Solar Flex installation, 400 watts worth of panels, so I thought I'd give you a little video tour and see what I've been up to and see how it turned out. So we'll go and look at the batteries that I moved underneath the street side bed, and I'll show you how I put that together, how that came out. Okay, here we go. This is the 1960 Airstream Ambassador, and this is the street side bed. I have the mattress moved over to this side. So what I did is I moved both batteries together under this bed. They're AGM batteries, 100 amp hour Lifeline batteries. There's one, and there's the second one. They are 12 volt batteries, so they're parallel together with 1/0 cable. And I wanted to show you guys these really cool fuse holders made by Blue Sea. They're called terminal fuses. Let's see if I can get that shot. So what it is, you take the terminal fuse holder, you attach it right to the top bolt of the positive terminal, and then the fuse itself is this little square 1-inch block here. And they come in a variety of sizes. I think they go down as low as 30 amp all the way up to 300. I have 175 in here. This wire's going to the other battery over there, and it's just parallel in the batteries. So I like to have a fuse in case something happens to that wire, and this was the cleanest way to do it. I know you can, everybody says you can go 18 inches away, but you know, my batteries are within 5 cable feet of each other, and I just wanted to have a fuse right on the battery. So these Blue Sea terminal fuse holders are great. Really like it. And the nice thing too is they fit underneath the battery box cover. Because that one, the second battery over here, where all my power comes off of, it has a 2 terminal holder, and one terminal holder from this one ties into that battery with another 175 amp fuse, and then I have a 125 amp fuse leading from this battery over to this distribution point. So that distribution point comes into this lead here, this number 4 wire. These fuses, and they tie into the 3 different fuse blocks that I have in the trailer. I have there's one fuse block here, there's one underneath the front near the front couch, and then one on the curbside bed. And then this fuse holder here takes power in from the converter, and then power in from the solar charger to charge the batteries. This here is a 500 amp shunt, and it is used to feed information to the trimetric battery monitor. All power goes through these grounds. This ground here comes from that battery and goes through the shunt, and then all other cabling here for the whole trailer goes through that shunt, so that the trimetric can read everything coming in and out of the batteries. So that's pretty much up for those wiring upgrades. Didn't seem like much, but it was a lot of work. Okay, let's look at the GoPower Solar Flex panels. Got this ladder set up here so we can climb up and have a look. Let's see, so I have 4 panels. I have 2 there, and I have 2 in the front. And the way it works is you can easily tie 2 panels together with a bridging connector that comes with the expansion kits. Normally you buy one kit, it comes with the solar panel, controller, and a cable. And then when you want to expand beyond 1 panel, which is 100 watts, you get an expansion kit. The expansion kit comes with another panel and bridging clips that bridge the 2 panels electrically together. And when you go beyond 2 panels, it gets a little more complicated. You have to build some kind of junction box, and I'll show you that in a minute. So that's all it is. You can see there's still quite a bit in the shade doing this. My house blocks the morning sun, so I only have I don't know, 2/3 of power available coming in. So the main lead comes in here. See if I can get a shot through the refrigerator. That's what feeds the refrigerator vent. That's what feeds the power to the trailer. I'm just going to hold this over, see if you can see that coming in. And I just held the wire down with foil tape, aluminum foil tape. And the panels are actually mounted with a 3M VHB very high bond tape. Can't remember which model it is. I'll put it in the description. I was going to also put some sealant around it, some Sikaflex, but I contacted 3M and they said there's no need for that. You don't need to protect their tape from water or UV rays, so I'm just going to go with it like this. It's got a real clean edge and I don't want to mess that up. I like it. So that's it for the install. No holes on the roof. Okay, so we'll go back inside and look. So just go over it again. The wiring from the panels on the roof, they come down through the refrigerator vent. There I used some Blue Sea bulkhead terminals that allowed me to drill holes through the side of my vent and put in these terminals, these bulkhead terminals, to allow the connection point at the roof. What that did is that created a junction box of sorts, which allowed two panels in the back that I paralleled together with the MC4 bridging clips that come with the expansion kit from GoPower, and then the front two with the bridging clips. Those brought in two wires to the terminal block, and I'll put a picture of that, close-up picture of that, so you can see it right now. And from there, that other side of the terminal, the bulkhead terminals, I ran a number 6 wire down the refrigerator vent into the trailer and up to the point where it meets the charge controller. Okay, so let's go back to the electrical area here. The solar panel wiring comes into this another Blue Sea device. I guess I like Blue Sea stuff. That's a 30 amp circuit breaker, but really in the configuration I'm using it's really just for a maintenance cutoff switch, because as long as there's sun, there's going to be power on this wire coming in. So if I needed to pull the charge controller out to do any kind of work on it, I'd have to either put some kind of blankets over the panels or wait till nighttime or whatever. And with this, I can just turn it off, a disconnect, and be able to pull the charge controller out. The reason it's not really protecting anything, because you always should protect power sources at the you always put the fuse or circuit breaker at the power source. So that really should be on the roof if I'm worried about protecting the panels, because even though they are solar panels, you do not want to short them out. You can blow the internal diode inside of them if they're generating power. So you have to be very, very careful about both polarity and not shorting them out. So basically this is just a maintenance cutoff switch for me. So this wiring goes into the closet there where I mounted the charge controller. And the reason I mounted it over here instead of in my pantry panel is because it really needs to be as close to the batteries as possible. You want to limit those cable runs. Okay, here's the GoPower charge controller, and it has it's a 30 amp PWM pulse width modulation controller. And basically what that means is it charges the batteries by turning the solar power on and off very rapidly depending on how much the batteries need to be charged. It is a 3 or 4 state charger. It'll do a rapid charge, a standard charge, and like a maintenance charge. It'll also do equalize lead acid batteries once a month, but it won't do it for, of course, AGM batteries, which don't require it. It has a maximum power boost mode, so at the end of the day you can push and hold this button here, A, and it will cause this to charge the batteries up at about 14.5 volts for I think 30 minutes to try and get the most out of the sun. You might do it toward the end of the day, get the most power into your batteries as possible before the sun goes down. So you can cycle through using B. This is volts, 13.5 volts on the batteries. The batteries are, of course, 100% charged. They have been for a while. And this is the number of amps coming in from the solar panels. I got 14.4 amps coming from those partially shaded panels, 400 watts. These panels should, in full sunlight, and of course you have to need to draw it because it's not going to just shove power in here. So you have to have a reason to draw it. So if you're drawing current like I am on purpose, having all these lights on, it can supply, I think, up to about 23 amps from these 400 watts. Each panel's, I think, rated about 5.6 amps. So there you go. It's been working great. Like I said, I haven't had to have my charger converter plug in at all. So we are charging almost 15 amps. We're coming in from the sun right now. And like I said, the panels are still partially shaded on the roof. So I have all the lights in the trailer turned on. And like I said, they're filament bulbs. And evidently those and the Wi-Fi Ranger and the detectors and whatever other parasitic loads I have are drawing 15 amps. Okay, so that's all coming from the sunlight, from the 400 watts. Now let's go look at the trimetric, which will tell us the net power use. Okay, so 0.4 amps is going back into the battery. So we're running all of these lights and we're charging the batteries. And like again, the charge converter, the AC converter is not plugged in. So this is all from solar. So there you go. That's what solar can do for you. Batteries are of course full, 12.9 volts, and now we're getting 0.7 amps of charge. Probably the sun is coming up over my house and getting the panels in more sunlight. So there you go. That's the GoPower solar flex system with 3 additional panels. So that's it for my tour of my GoPower solar flex system. Again, I have the solar flex kit that includes the controller and a 100 watt panel, and then I got 3 additional 100 watt expansion kits to complete the system. We haven't camped with it, but I'm sure it'll perform well. There's no maintenance to it other than keeping the panels clean. The panels have a 10-year warranty, so I expect that this will last for quite a long time. Very pleased with the way they look. Again, since this is an Airstream that's rounded, I wouldn't want to put the glass and aluminum flat panels on the roof. Those have to be raised up high and to allow cooling underneath, and it just wouldn't look right on an Airstream, especially a vintage Airstream. Some of the newer ones that are wide body, you might be able to get away with it. There's a lot of stuff going on the roof with those. But with an older, like mine, 1960, it has much more of a curve to it. These panels, they can curve up to 30 degrees, and they just follow the shape as you saw of that. You can't even see the panels, you know, when you're walking around near the trailer. So it's a really, really great benefit having the flexible panels for, you know, especially something you want to keep looking at as original as possible, like a lot of us like to do in our vintage Airstreams. So I hope you enjoyed this. If you have any questions, feel free to contact us. I'm at theVAP.com for the Vintage Airstream podcast, and of course all of the work that I've done on the trailer here you can find at blog.thevap.com. All right, thanks.